So we're starting a chapter today on sequences and series. Today's lesson will sort of cover two different skills. The first skill will be a vocabulary-based skill, identifying what type of sequence that we are looking at, whether it's arithmetic or geometric or neither. And then our second skill will be focused primarily or specifically on arithmetic sequences. It will be asking us to find the nth term, okay? So here we go. Okay, we're going to get down to business here. A sequence is a list of numbers in a particular order. Okay, so here you see a list of numbers in an order. Okay, you notice that 1, 5, 9, 13, 17, 21, 25, 29, there's a pattern to that sequence, okay? There doesn't necessarily have to be a pattern, but there usually is a pattern, so we need to find that, okay? Sequences can either be finite or infinite. Those words being opposite, finite meaning limited, infinite meaning unlimited. In other words, we're referring to the length. This particular sequence is infinite, noted by the 3 dots indicating that that list of numbers continues, okay? We could just as easily have a finite list, something along the lines of 3, 5, 7, 9, 11, 13. That is a limited sequence, but it is still a sequence, okay? So finite means it ends, infinite means the list would go on forever, okay? It's that simple. Our focus is going to be pretty much on infinite sequences. But when we talk about series, that will be focused more on the finite lists, okay? So take your screenshot if you want one. We're going to advance to the next screen. You can always come back later if you need a screenshot later. Okay, so in Algebra 2 here, we discussed two types of sequences. Arithmetic sequences, as in arithmetic, okay? This type of sequence has a constant addition or subtraction pattern to it, okay? So for example, that one we just looked at a minute ago, this is an arithmetic sequence. And the way that we know that is the pattern is that each term is created by adding 4 to the previous term. Okay? That 4 is known as the common difference. We will use the letter D to represent that. Okay? And we'll talk more detail about vocabulary here in a minute once we discuss the other type of sequence. So the other type of sequence that we're going to talk about in this particular class are called geometric sequences. These have a constant multiplication or division pattern. Okay, so for example, something along the lines of 1, -3, 9, -27, 81, negative 243, 729. Okay, that has a pattern as well. The pattern is that we are multiplying by negative 3. That negative 3 we're multiplying by is known as the common ratio, and we will represent that value with a lowercase r. Now, we're not really going to spend much time talking about geometric sequences today. We're going to be focused in on arithmetic sequences. But the first skill we're going to practice, the first one that's going to be assigned to you in your homework assignment tonight, is being able to tell whether a sequence is arithmetic, geometric, neither, or potentially, and it doesn't happen very often, both. Okay? So arithmetic sequences have a constant addition or subtraction pattern, and geometric sequences have a constant multiplication or division pattern. Now notice the word constant in there. What that means is that it can't be like +1, +3, +5, +7, +9. That's not a constant pattern. It has to be the same number being added every time, the same number being multiplied every time. Okay, that's why the word constant is in there. Take your screenshot if you want one. We're going to advance to the next screen very, very shortly. Okay. So this is the first skill, is determining whether a sequence is arithmetic, geometric, or neither. There are not going to be any examples in the notes today of both, but I will write one in at the end so that we see one, so we know how to recognize it when it's both. So what we're doing here is we're looking for a pattern. We're looking for either addition or a multiplication-based pattern. Now remember that addition and subtraction are really the same thing, so if it's a subtraction pattern, that's the same as an addition pattern. And multiplication and division, those are really the same thing. So if we find either one of those, that makes it geometric. Okay, so a constant addition pattern would be arithmetic. A constant multiplication or division would be geometric. So we go in here and we find a pattern. Well, -4 plus 5 is 1. 1 plus 5 is 6. 6 plus 5 is 11. 11 plus 5 is 16. So we have a common difference of +5. We're adding 5 every time. That makes this an arithmetic sequence, because the pattern is we are adding 5 every time. Okay? That means it's got a constant addition pattern, which makes it a common difference of 5. Okay? So then on the next one, there is a pattern, but the pattern is not as obvious. It's a little bit harder to spot. It's still an addition-based pattern. We start with +2, then +4, then +6, then +8. So the next term would be +10, then +12. So there is a pattern to it, but that difference is not the same number every time. So this would be an example of neither. Okay? It's an addition-based pattern, but since that is not always the same number being added, it does not fit the description of arithmetic. Okay, it has to be the same number added every single time for it to be an arithmetic sequence. So since there is a pattern that's addition-based, that's cool. It's great that we can find the pattern, but it has to be the same number every time or it is not arithmetic. Okay? The final example here on this page is a multiplication-based pattern. Every time we are multiplying by 2. This would be an example of a geometric sequence because r equals 2. We are multiplying by 2 every time. Okay? So that makes it a geometric pattern. Now there's also an addition pattern to that sequence. Plus 4, plus 8, plus 16, plus 32. Okay, but you need to see the multiplication pattern. And that's probably the big challenge here, is telling the difference between multiplication and addition. Okay, if the number that it's increasing by is changing, look for a multiplication pattern. Always start looking for an addition pattern. And if you can't find an easy addition pattern, check for multiplication. But you need to be, that's the big challenge here. It honestly is. It's telling you that it's a multiplication pattern and not just an addition pattern, because technically there is an addition pattern here as well. It's not a constant addition pattern. But what we do need to notice is that even though this isn't constant, the amount being added is being doubled each time. It's being multiplied by 2, right? That indicates that there's a multiplication pattern to it. Okay? Because the amount you're having to add is doubling. That implies there's actually a multiplication pattern. Okay? And that's a big, that is the big challenge of this, is telling that when it's a geometric sequence, when is it a multiplication-based sequence, okay? But if you notice, the amount that we're having to add is going from 4 to 8 to 16 to 32. That's being multiplied by 2, okay? So you should be able to spot the pattern, the multiplication pattern, in the non-constant addition pattern, if it's a multiplication pattern, okay? Let's do a couple more of these. Grab a screenshot if you want one, and we're going to scroll down and do, I think, 3 more. And then I will show you an example of when it's both. They're really boring and pointless, but it's going to come up on your assignment. So we need to make sure we understand how to tell when it's both. Okay? So get your screenshot. Okay. So here's 3 more examples of arithmetic, geometric, or neither. And again, we're looking for a pattern here. So in that first one, we should see the pattern is that we are subtracting 4 each term, which is the same as adding -4, which is why I say there's no difference between addition and subtraction. This is an arithmetic sequence. Okay, with a common difference of -4. Okay. On the next one, this one's kind of tricky, but if you notice, the term, each term is half of the previous term. So you could either recognize it as being dividing by 2, or if you're good with fractions, you might notice that we're actually multiplying by 1/2. Okay? So we're dividing by 2 or multiplying by 1/2 each time. So that would be a geometric sequence because we have an R value of 1/2. We're multiplying by 1/2 each time. You could also say dividing by 2 to explain your reasoning. That'd be perfectly acceptable. Okay, but keep in mind that the R value will be what you have to multiply by. So it will be a fraction. If there's a division pattern, then R will be a fraction. The other thing to notice with a geometric pattern is anytime the sign is changing from positive to negative, that is usually a geometric pattern. Okay? Because that means you're multiplying by a negative number, which is changing the sign back and forth between negative and positive. So just another helpful hint to see. Okay, and on this last one, this pattern's kind of hard to see because we're dividing by 2, but then we divide by 3, then we divide by 2 again, then we divide by 3. So that would be another example of a sequence that is not either, okay? Okay, the pattern is multiplication based. But it's not constant. It has to be the same value every time, or it's not a geometric sequence. Even if it's based on multiplication division, it has to be the same number every single time. Okay? Now, let's talk extremely quickly about both. So the only way you can have a sequence that is both arithmetic, and geometric is if every single number in the sequence is the same number, okay? The reason this would be both is because it has a constant addition pattern. We're adding 0 over and over and over and over again, which makes it arithmetic. And we are multiplying by 1 over and over and over and over again, which makes it geometric as well. So the only way it can be both arithmetic and geometric is if it is the same number throughout the entire sequence. So for instance, the example there, 2, 2, 2, 2, 2, 2, 2, that's an example of a sequence that is boring, but it is both arithmetic and geometric. Okay, don't let that trick you on the homework this evening. Okay, so what I'm going to do here is I'm going to pull up this whole page, get rid of my screen here so you can get a good screenshot of the whole page if you want it, which I'm kind of hoping it will recenter itself. There it goes. Okay, grab that screenshot if you want it, and then we're going to advance to the next page. And it just bounced away again, didn't it? There we go. Okay. So moving back down here, we go into, now we're just going to focus in specifically on arithmetic sequences, okay? So an arithmetic sequence, as we said before, is a sequence with a constant, that is a very key word, addition or subtraction pattern. So for example, we have an arithmetic sequence here, 2, 6, 10, 14, 18, 22. Okay, the pattern that we should see there is that every term is the previous term plus 4. Okay, so we need to notice we need to talk vocab a little bit here. First of all, we've already said once, but I'm going to say it again, that 4 is the common difference. Which we're going to represent with the lowercase letter d. Okay? The 2 is known as the initial term and is represented with the notation a sub 1, a subscript 1. Okay? Because the term number of that's the first term. So it's a sub 1, meaning the first term. Okay? Every term in here has notation that goes with that. So 6 would be A2, 10 would be A3, 18 would be A5, etc. Okay? every term can be represented with an A and a subscript representing the term number. Now, we can represent any arithmetic sequence with the following equation. The nth term, a sub n, is equal to the first term, a sub 1, plus d times n minus 1. So a sub n is the nth term. A sub 1 is the first term, or initial term. D is the common difference. And n is the term number. Okay. So we're going to be using that equation over and over and over again. Even if you're not taking notes, you may want to write that equation down somewhere. Grab a screenshot, and we will continue on into the applications, and I'll make sure to point out the one that's going to be on your homework this evening, the application that's going to be on your homework, so we can make sure that everybody's paying close attention. Okay, once you got your screenshot, we're ready to go to the next screen. So here we go. So the skill, and this is the one you've got to be able to do, is finding the nth term. And when I say nth, there's going to be a number given. It'll say find the 12th term, find the 30th term, find the 45th term. Okay? So we have to use the information they give us to come up with enough to plug into our equation. Okay? So we're going to use our equation. A sub n is a sub 1 plus d times n minus 1. Now we need, there's 4 variables there. We need 3 of them to be able to solve for the 4th one. We have 3 of them that's given in the directions. We were told to find the 12th term, which means n equals 12. We know the first term in our sequence is 9. And we can see the pattern is that we are adding 7 each time, which means our common difference is 7. So we're going to take those values and we're going to plug them in to our equation. So that would be the nth term, which in reality we shouldn't write a sub n anymore because we're asked to find the 12th term. So the 12th term, a sub 12, is equal to the first term, 9, plus the common difference, 7, times the term number 12 minus 1. Then we just simplify that down to a single number. So that would be the 12th term is 9 plus 7 times 11, or the 12th term is 9 plus 77, which means the 12th term would be 86. 86 would be the 12th term in the sequence. Now you could get there by just extending the sequence. And for low term numbers, that's not any harder, and it's perfectly acceptable if that's how you want to approach it. But what if I were to ask you for the 4,535th term? I don't think most of you are going to want to write the sequence out that far. See what I'm saying? So we need to be able to use the equation to do it, especially since we're not in Algebra 1 anymore. We're in Algebra 2. We ought to be able to manipulate the equation and use it. Okay? Let's do another one. So here we're asked to find the 9th term, which means n equals 9. The first term in the sequence is -4. The pattern is that we're adding 6 each time. So D is equal to 6. So we have D equals 6, A1 equals -4, N equals 9. We plug into our equation to find the ninth term. So A sub 9 equals the first term, -4, plus the common difference, 6, times the term number 9 minus 1. So the ninth term is -4 plus 6 times 8. The ninth term is -4 plus 48, or the ninth term is 44. Okay, this is the skill that we're going to work on Delta Math tonight. Your assignment will actually have a Delta Math component and an IXL component because the Delta Math doesn't have great practice for the other skill we need to practice. Okay, so we've got an A sub 9 is 44. Grab your screenshot if you want one. We're going to move to the next screen in about 10 seconds. I know we're running a little bit longer today than we usually do, but it's necessary today. Okay, it's necessary today. So hopefully everybody's gotten their screenshot if they want one. These notes will go up on Classroom along with the video later on. Okay, so here's some more. Now, this is a little bit different skill because now we're being asked to write an equation for the nth term instead of finding the nth term, which means when we write our equation, we'll still have two variables that we don't know. That is A sub n we won't know, and n we won't know. But even here with these patterns, we should still be able to find the first term, A sub 1, and the common difference by finding the pattern. Okay? So we go in here and we say, all right, on this first one here, the first term is 5, and I am subtracting 18 each time, which means the common difference is -18. So my equation is still based on the same, oops, that should be A sub 1. Same equation we used on the last example, but this time we don't know the term number, so we can't plug in for n like we did in the previous two examples. We have to leave A sub n, plug in A sub 1, which is 5, plug in D, which is -18, and we have to leave n in there as well. So then from there, all we need to do is simplify. What I mean by that is we're going to distribute -18, which would give us A sub n equals 5 minus 18n plus 18. And then we're going to add like terms, which would give us A sub n is -18n plus 23. This would be the equation for the nth term of that arithmetic sequence. So then I could turn around and I could say, what's the 25th term? Plug in 25 for n, and you've got your number. What's the 35th term? You plug in 35 for n, you've got your number. Okay? That is called the explicit equation for that sequence, because all you need to know to find a specific term is the term number. Okay? So let's do another one. Switch colors so we know that work goes with the other one. A sub 1 is -8. Look for the pattern. We're adding 2 each time. So the common difference is 2. Start with our generic equation for arithmetic sequence, which is A sub 1 plus D times n minus 1. Plug in what we know. Okay, we know the first term is -8. We know the common difference is 2. Distribute the 2. Gives us A sub n is -8 plus 2n minus 2. Combine like terms. And the nth term, oh, what happened? I don't know what that was. I've made it angry. the nth term I have no idea what's going on with my pen right now. It's acting like it switched to the text tool. One second here. Okay, so then we just add the like terms, and we get the nth term is 2n minus 10, which would be our explicit equation. All right, grab your screenshot if you want one. I'm not sure we have a ton left to do here. We're just going to do one more set of examples, and then we're done for the day. So 2 more examples. Okay, I hope everybody's got their screenshot. So here's a slightly more advanced version of the same thing. It says write an equation for the arithmetic sequence described. Well, they didn't give us the first term. They didn't give us the sequence. They told us what the 5th term was, and they told us the common difference. So this is going to be a little bit trickier. Okay, we're going to start with our equation. A sub n is a sub 1 plus d times n minus 1. And we're going to plug in what we know. Okay, what we know is if we let n equals 5, then a sub n is 19. So I can plug the 19 in for a sub n. I don't know a sub 1. D is 6, and n is 5. So I plug all that stuff in. No, your assignment tonight will be to find the nth term. So it'll be the first skill we did. I'll talk about that more in a minute here. What we do is we solve for a sub 1. So we do 5 minus 1, which is 4. Then we do 6 times 4, which is 24. And then we solve for a sub 1 by subtracting 24 from each side. That gives us the first term is negative 5. Then we turn around and we go back and we do it again. But this time we leave it, just like we did on the previous page, we leave a sub n and n in the equation and only plug in the first term and the common difference and do exactly what we did on the previous page. So we distribute the 6. And then we would combine our like terms to give us our final equation. So our answer would be the nth term is 6n minus 11, which is our explicit formula. Okay, so if they don't give us the first term, it becomes a 2-step problem. We have to find the first term and then find the equation. Okay, and we will eventually have an assignment over this, but it won't be until after we've discussed geometric sequences as in addition. Okay, so this is going to come up eventually on a Delta Math assignment, but not today, probably Tuesday. Okay, let's do one more of these. Okay, again, they tell us that when n equals 6, a sub n is 12. So we start off and we find a sub 1. And we do that by plugging into our equation everything that we know. That is that when a sub n equals 12, n is equal to 6, and d is equal to 8. So now we're going to solve that for a sub 1. 6 minus 1 is 5. 8 times 5 is 40. Subtract 40 from each side, and we get a sub 1 is negative 28. Then we turn around and we solve for the actual equation. So we're not going to know the nth term. We're trying to write an equation for it. First term is negative 28. D is 8. And we're trying to write it in terms of n, so we don't want to put an n in there. Okay? Distribute the 8. So a sub n would be negative 28 plus 8n minus 8. Combine like terms. A sub n is 8n minus 36. Okay, so we've completed the notes. I want to very briefly, very briefly, discuss what your assignment is for today. Okay, but before I do that here, I'm going to stop the recording because we have finished the lesson.